Let's take a look at the implicit differentiation and related rates review worksheet. This will be in a couple of videos, and we'll do a few questions on each video. So here's question one. It's x's and y's mixed together, and they're asking for dy dx. So this is going to be straight implicit differentiation. This is not a related rates question. You're not taking the derivative of anything with respect to time. So take your equation, differentiate each term. Just every time you have a y term, you have to multiply its derivative by dy dx. And also, anytime you have two variables together, you have to use the product rule. So if I go through here, right, derivative of 3x squared is 6x. The 2 times xy is that product rule because of the x times y. That gives us that. And the derivative of y squared is 2y, and again times dy dx because it's a y term. Derivative of any constant is 0. So if I clean that up a little bit, it's going to look like this. And if you remember the way implicit differentiation works, you group all the dy dx terms on one side of the equal sign and move everything that doesn't have a dy dx to the other side. So that's going to look like that. Then you factor out the dy dx, which gives you this, and then you divide both sides by the other factor. So you wind up with dy dx on the left, and then some expression on the right. Now, none of the answer choices match this, but there's a GCF that you can factor out of the numerator and the denominator. Right? I can take a -2 out of the numerator and a 2 out of the denominator to get this. They will subsequently cancel out. And then I have something that matches an answer choice here for number 1. And there we go, it's choice B. On to question 2. Also implicit differentiation, but now you've got x's and y's in the input of a natural log function. So there's our equation. Remember, the derivative of natural log of something is 1 over that same input times the derivative of the input. But again, this is implicit differentiation, so every time you have a y term, you have to multiply its derivative by dy dx. So that's going to give me that for the 2x plus y. On the other side of the equal sign, the derivative of x is 1, and the derivative of the constant 1 is 0. So I'm trying to solve for dy dx. What I'm going to do here is multiply both sides by 2x plus y. That will give me this, right? 1 times 2x plus y results in 2x plus y on the right side. Then I can just subtract the 2 from the left and the right sides to get dy dx. There it is, and that's a match to answer choice B. Okay, on to question 3. Again, implicit differentiation here, but this time they want to know what the derivative is equal to when x is equal to -1. So there's a few things we're going to do here. First, we'll just start off with the regular implicit differentiation. You can see I have x times y, so I'll need the product rule there. So the derivative of y is dy dx. The xy will give me that product rule. The x squared term will give me 2x. And of course, that plus 1 is a constant, so its derivative is 0. All right, when you clean that all up, you get dy dx is equal to all of that. We've got to group the dy dx terms on the left. And we're left with the y plus 2x on the right. Then we factor out the dy dx and divide both sides by the other factor of 1 minus x. Now, if the question gave you answer choices that were in terms of x and y, we would try to match an answer here. But they want to know what dy dx is equal to when x is equal to -1. Now, I'm sensing a little bit of a potential issue here because the derivative, dy dx, is in terms of both x and y. But if I substitute in x equals -1, I get that little business there. And sure enough, there's a y that I don't have, and all my answer choices are numbers. So I need y. So how am I going to find y? Well, I'm going to take what I know dy dx to be already with x equal to -1, and I'm going to solve for y in the original equation. I just replace all the x's with -1, and I wind up with a y value of 1. So when I substitute that back into my derivative, I get 1 minus 2, or negative 1 over 2, and I get a choice B option here. dy dx is equal to negative 1/2. All right, on to the next. Question 4, this is a second derivative. It's also at the point 4 comma 3. So I'm going to find my first derivative first. Again, implicit differentiation. And we wind up with this. Move the 2x term to the other side by subtracting it. Divide both sides by 2y. The 2's cancel out. And I'm left with dy dx equals negative x over y. Right? So now, once I have that, now I'm going to go and I'm going to look for my second derivative. I just want to make a little point here, though, that if we're using this and finding the second derivative at the point 4 comma 3, it's probably helpful to figure out what dy dx would be at 4 comma 3 first. In this case, it's negative 4 over 3. You'll see why we're doing that here in just a moment. So now I go and I find the second derivative. So it's going to be quotient rule, low d high minus high d low over low squared. And I'm using negative x over y and differentiating that. Now I'm going to substitute in 4 for the x's and 3 for the y terms, and for dy dx, negative 4 over 3. So I get that substitution, and when I solve and simplify, I wind up with negative 25 over 27, which is equal to choice A. All right, one more question on this video before we go on to the next. Here we go. Slope of the tangent line here, and this is a calculator question, perhaps, although I don't know that we'll need it. We'll see. So slope of the tangent line is dy dx. They're just masking what they're asking you for by calling it slope of the tangent line. All right, so I'm going to take my equation. We just did in an earlier problem the derivative of natural log of something. This time it's a product rule on the inside. So 1 over the input times the derivative of the input, there's your product rule, equals the derivative of x, which is 1. Clean that up a little bit. And again, I multiplied both sides by xy. Now I'm going to get the dy dx term by itself by subtracting y from each side and dividing both sides by x. All right, not done with the question yet. Now I have to substitute in an x value of 1. So when I do that, this is what I wind up with. And in that numerator, if you notice, y minus y is going to give me 0. So that's a match to answer choice A. All right, we'll continue with the later problems in the next video.